Alright guys, so this is the example problem section or video for the reintroduction to vectors. I'm using a website called Physics Info, which has practice problems. There's also going to be a practice worksheet for you guys once this gets done. So we're going to jump into it, and hopefully we won't be more than like 5 minutes in this video. So jumping down to our first practice problem, and I'm going to enlarge this real quick. So it says two people are pushing a disabled car. One exerts a force of 200 newtons east. The other exerts a force of 150 newtons east. So what is the net force exerted on the car, assuming there's no friction? So what we're actually looking at is an addition problem of two vectors. So we have a vector 200 going east and another vector of 150 going east. So we end up with 200 plus 150. If we draw it out graphically, what we're going to see is both forces are being applied. So we can put these, using the head to tail rule, we can put these two together, and I should end up with a resultant vector that gives me 350 newtons. Does that make sense to you guys? Hopefully. So a couple things. Make sure that you're doing graphical illustrations. It will help you, even if it's just hand scratched and not on graph paper. So if we look down at the math, you have vector A, or force 1 in this case, and vector B, which is F2. So the addition of those 200n plus 150n gives me 350n. So it's relatively simple. So looking at practice problem 2, we have two soccer players kick a ball simultaneously from opposite sides. Red number 3 kicks the ball with 50 newtons of force, while blue number 5 kicks the ball with 63 newtons of force. So what is our net force on the ball? So this problem I would actually look at and say that it could go either way because it doesn't specify who's on what side of the ball. But so if we draw out our diagram, I have one foot kicking one way, going 50 newtons, and another foot going the opposite direction of 63 newtons. So if we're adding these, what I'm going to end up doing, because this one's going the opposite direction, is one of these is going to be negative. So it's either, in this case, should be negative 63 the way they have it drawn. So the forces are going to point in opposite directions, so we can either subtract our 63 or we can add the negative of that value. Both are the same thing. So we have our red player kicking plus the negative of our blue player, or in this case, subtracting the force of the blue player kicking it, and we end up with negative 13. So notice we didn't have any cardinal directions. So in the problem, they arbitrarily just assigned which one value to be negative and one value to be positive. So it could be possible that your answer would actually be positive 13. So just keep that in mind. Or you could write it in relationship to the two players. None of those are really more correct than the other. Ideally, we don't see problems that are going to give you that multiple correct answers. So looking at practice problem number 3. So we have an airplane that heads due north at 100 meters per second through a 30 meters per second crosswind blowing from the east to west. So determine the resultant velocity of the airplane. So whenever we're talking about crosswind, that wind is blowing into the side of the plane. So what's actually happening is my plane is going north, and I have a wind blowing east to west this way. So I have these two vectors, and we have to add them in some manner. So because we know they're perpendicular, obviously using head to tail method we talked about. So notice here, I have a triangle, right? And I have a perpendicular right angle, which means I can apply Pythagorean's theorem, which is a squared plus b squared gives me c squared. So if we apply the resultant, so we have 100 meters per second squared, 100 meters per second, that quantity squared, plus 30 meters per second, that quantity squared. We end up with those two values equals v squared. So if we work it out, we end up with 104 meters per second. Obviously, their answer isn't taking into account sig figs, but relatively easy to do. And we're going to have to break into sine, cosine, and tangent whenever we run into problems where we have these triangles. This is just showing you an example. So in this case, we were given the values of the opposite and the adjacent to our hypotenuse. So we're going to use tangent. So we have 30 meters per second over 100 meters per second, which gives us an angle of 17 degrees. So my vector would be moving 17 degrees west of north. So with that being said, we're going to stop it there. Hopefully that makes sense. And if you guys have questions, bring them Tuesday. All right.